Welcome back to another video on solving PMO problems. We have here a radical equation from the 14th PMO area stage. Solve for all real numbers x, satisfying x plus the square root of x minus 1 plus the square root of x plus 1 plus the square root of x squared minus 1 equals 4. We all know that the standard method of solving radical equations is by isolating a term involving a radical expression and then squaring both sides of the equation and repeating this process until all radicals are eliminated. However, this method is inefficient when there are more than two radical expressions in the given. So in this video, I will show you another method to deal with radical equations. To get started, let us determine the domain. Let us check the values of x that can be admitted for each term. Take note that the expression under the square root must be non-negative. Let us start with the square root of x squared minus 1. We need x squared minus 1 to be greater than or equal to 0. So, x must be less than or equal to negative 1 or greater than or equal to 1. For the term square root of x plus 1, we need x plus 1 to be greater than or equal to 0. So, x must be greater than or equal to negative 1. Similarly, for the term square root of x minus 1, we need x minus 1 to be greater than or equal to 0. So, x must be greater than or equal to 1. And for the last term, x, we can actually have here any real numbers. Okay. But we need the domain of the entire expression. So we just have to determine the intersection of these four, and the intersection is just x greater than or equal to 1. So the domain of this entire expression is just x greater than or equal to 1. In the meantime, let us set this aside. We can actually use this one in the latter portion of our solution. Okay, so now this is the original equation, and what I'm gonna do first is write the term square root of x squared minus 1 into the product of the square root of x minus 1 and square root of x plus 1. Now this time, I'll subtract 1 from both sides, 1 from both sides of the equation to get x minus 1 in the left-hand side. And take note that since x is greater than or equal to 1, x minus 1 is actually non-negative. So I can write x minus 1 into the square of the square root of x minus 1. Now let's call this equation equation 1. Let's bring back the original equation. This time, I'll add 1 to both sides, so that I'll have x plus 1 in the left-hand side. Again, x is greater than or equal to 1, so x plus 1 is greater than or equal to 2. So I can write x plus 1 as the square of the square root of x plus 1. Let us call this equation equation 2. Okay, this time we can apply the substitution method. I will let a be equal to the square root of x minus 1 and b be equal to the square root of x plus 1. If we replace these components with a and b respectively in our two equations, equation 1 becomes a squared plus a plus b plus ab equals 3. Similarly, equation 2 becomes b squared plus a plus b plus ab equals 5. Okay, so this time we have two simpler equations. Now let's add equations 1 and 2. If we do this, we get a squared plus b squared plus 2a plus 2b plus 2ab equals 8. Take note that a squared plus b squared can be written as a squared plus 2ab plus b squared minus 2ab. Also, a squared plus 2ab plus b squared can be written as the square of a plus b. Now take note that we have here negative 2ab and positive 2ab, so we can just cancel these two, and arrived at the equation a plus b squared plus 2a plus 2b equals 8. Also, 2a plus 2b can be written as 2 times a plus b. Now, let's subtract 8 from both sides to get the equation a plus b squared plus 2 times a plus b minus 8 equals 0. Now, observe that this equation can be solved by factoring. The left-hand side can be factored into a plus b plus 4 times a plus b minus 2. So this last equation implies that a plus b equals negative 4 or a plus b equals 2. So which equation should we take? Recall that the domain is x greater than or equal to 1, and we've let a to be equal to the square root of x minus 1 and b to be equal to the square root of x plus 1. So it follows that a must be greater than or equal to 0 and b must be greater than or equal to the square root of 2. So it's actually impossible for a plus b to be negative. So we eliminate this case. So we take a plus b equals 2. Let's call this equation 3. Now this time, I'll subtract equations 1 and 2 to get a squared minus b squared equals negative 2. Take note that a squared minus b squared can be written as a plus b times a minus b. Take note also that from equation 3, a plus b equals 2. So we can replace here a plus b by 2. Dividing both sides of this equation by 2, we get a minus b equals negative 1. Let's call this equation 4. The only equations that we can actually use here are equations 3 and 4. So let's set aside equations 1 and 2. Now let's add these two equations. If we do this, we get 2a equals 1. Dividing both sides by 2, we get a equals 1 half. Now recall that a is equal to the square root of x minus 1. So it is the case that the square root of x minus 1 is equal to 1 half. Now compare this to the original equation in the problem. This equation is much easier to solve, right? Now we can just square both sides. Simplifying, we get x minus 1 equals 1/4. And finally, solving for x, we get x equals 5 over 4. But we need to check this one whether this satisfies the original equation. So to do this, let us substitute x equals 5 over 4 in the left-hand side of the original equation and see if the result is 4. Simplifying, we have 5 over 4 plus the square root of 1 over 4 plus the square root of 9 over 4 plus the square root of 9 over 16. Simplifying further, we get 5 over 4 plus 1 half plus 3 halves plus 3 over 4. Adding, the result is indeed 4. And so the value 5 over 4 satisfies the original equation. And so we conclude that the solution is x equals 5 over 4.